Hang on.
And we're live.
There's
We're
Steve,
totally live.
Steve's chin.
We're live now.
Yes.
Hooray.
I have more feature-rich video feed from Steve. Scott, I can see his chin
Hang on.
and his.
I'm tweeting this. Can I say we're going to see a special announcement regarding blank?
Yeah, I think that was actually Damon actually tweeted something similar last night. So absolutely. And you can fill in the blank.
I'm going to say exactly what it is. Is that okay?
Yeah. The announcement's live at this point.
Zomagy. Zomagy. Okay, let's see how this works. Boom. Let's wait for this tweet to go live and go viral. Is anyone here yet?
Well, we just went online like the second.
So you're saying 1,000 people have not immediately shown up, is what you're saying?
Exactly. All right.
So it says standby starting soon, dude.
I know you're always like one step ahead of me. All right. It is now updated.
Behind, actually.
Well, we were waiting 10 minutes, to be fair. The stupid YouTube thing or Google Hangout, I invited you probably about 50 times.
Dude.
You got
Never saw a chat. Just saying.
I can't apologize for Google
your
services
fault,
enough.
I blame myself. All right. Here we go.
Well, showing up. Hello.
Eric says there's 1,000 people in the room with him, so we can count those people.
So we have 1,064 people online.
Do me a favor, and this is a total nit. Would you lower your camera to an appropriate, like put your head center? Because I'm looking at your ceiling.
I'll just sit higher.
Why don't you just move your camera?
Why don't you move your camera?
Because my camera is perfectly positioned.
All right. Okay. Am I centered for you?
It's adequate at this point. It's not as nice as Steve's chin, but it's nice.
Yeah.
Do you remember
I just
when
like people to think that?
One time Maxime went on and he took an angle and he made sure which of my things on my wall were straight. There's one picture on my wall that's not straight just to bug him. But
is that why you did that?
I did that.
No, I can't unsee it now.
Hooray. Okay, well, we've got tons of great stuff. I mean, I kind of want to like jump into the community links because they're cool, but then we can get on with the exciting demos, announcements. Good?
Sounds great.
All right, I'm going to share my screen. Dun, dun, dun. Sharing screen. Hooray, okay. First of all, Shane Boyer. So we have had this workshop that we've done several times, NDC conferences, Dev Intersection, etc. So this is this app server or build a website. It's a conference planner using ASP.NET Core. It uses API backend. So what's cool in here is this has been updated to use the new ASP Angular CLI-based SPA front end, and it's also got a cool Docker deployment. So this is Shane's. We just merged this this past week. This is Shane's updates to this thing. So it's an entire lab that takes you from file new project to building out an entire thing with a website, a single page app front end, and deploying with Docker and Helm. So very cool, high quality work from Shane, of course. So that's exciting. And this is a relatively quick blog post. The actual, what you're not seeing and you will see when you click through is there's a ton of markdown in here too, explaining now you'll do this. This is what this next step does, etc. So
can you lock the camera?
Yes. Cool. So there's that. The next one is Steve Gordon, and Steve Gordon is continuing a series he's done on deep dives. So this is going way deep into the code, how things are actually working. Here he's talking about how use startup works. So this is a long, very meaty post talking about how things are registered, which things are convention based. So this is by the time you finish this, or if for some reason you need to do something complex, with startup, application startup, the web host builder, all that stuff, bookmark this and come back later. This is really in depth and stepping through exactly how and why things are working the way they are. So Very, very nice post. Here's another one on OIDC. This is from Damian Bowden, and here he's talking about securing an ASP.NET Core MVC application with secure API. So nice diagrams, continuing to work through how the flow works, etc. By the way, Damian pinged me offline, and he was asking about. I don't know if he linked to it. I didn't see a link to it in here. He was asking about in the MVA that we did recently, where we talked about using two-factor auth, and he pointed out to me that really what we were using in that case is more technically correctly called two-step auth. Two-step auth is where you have an app that pops up a code and you type that in separately. And so what I took out of my conversation with him is I should just call it multi-factor auth, which is the generic term, and I'll never be wrong.
Oh,
yeah.
I learned something there too. Didn't know that.
Yeah. So I mean,
I'll have to go correct it, Barry Dorans as well. Like Barry, I know security, but
I mean that's what Dr. Wikipedia told me. So. My screen went blank for a second there. That was cool. So Philip is digging into the API controller attribute, looking into which are the specific conventions, and the other kind of things you can tweak on it.
That's a new 2.1 feature.
Yes.
That's like playing around with like nightly builds. That's how he hasn't even shipped an official preview yet. But yeah, that's new in 2.1. That's some nice conventions.
I'm not sure if we have one scheduled on that. We're doing this series on 2.1 features. I don't know if we'll be digging into API specific stuff.
We should.
Okay. So,
but if people want to read about it, we posted the 2.1 roadmap blog post just like, what was it? Late last week, I think.
Yep.
So you can read all about it there as well.
That's one of my links coming up in a minute or two.
Oh sorry.
Yeah. No worries. Okay, so this is interesting. This is a new kind of front. Sorry, my words are not working well for me today. This is a web front end for F# and ASP.NET Core. This is the MVC pattern implementation. This is called Saturn. So we've talked before about Suave and Giraffe, and what I'm going to mangle his name. Oh, so it's just Christoph. So Christoph has said that he would like to see something working at a higher level of abstraction. To him, Suave and Giraffe are a little too low level, and it feels like he's building an MVC application using middleware, and he'd really like a higher level of abstraction. So that's what Saturn is. So it's a new web framework with F# and ASP.NET Core. So here's an example of some of the code. And then, of course, the code itself is all out on, so this is Saturn Framework. They've got a separate org for that, Saturn Framework Saturn. So this is out on GitHub as well. So, and as he called out here, I'm no expert on Elixir Phoenix. I did do Rob Connery's course about that, which was pretty cool. But so this is based on or inspired by Elixir's Phoenix as well. So I'm looking into digging into that more. All right. So this is very cool. This is from Ben Adams. This is something which is hitting in 2.1, I believe. It is something he did that's cool that affects all of .NET Core, but ASP.NET Core is one that's impacted as well. This is stack trace improvements. So the problem was that your stack traces in the past had all these things like method async D4, blah, blah, blah. It was all these, right? They're just not easy to read. So
like read every other line of your stack trace to really understand what's going on or something like that. Exactly.
So Steve has worked, or so Ben has worked on getting, readable stack traces. So this blog post goes through and explains what he did, and basically shows you, how you can get something that's actually more readable. So
I've heard a lot of people pretty happy with that.
And it affects exactly, and it affects everything. It's all of .NET Core. So, but you'll actually be able to read your async stack traces, which is very neat. So.
Thank you, Ben.
Hey, Ben. Okay, yeah. So here we've got 3 blog posts. These will, we share these links out afterwards, and so people can dig in detail. This is the .NET Core 2.1 roadmap. So Rich Lander talking about this. This is just high level, and then he, talking, some highlights with the build time performance, global tools. I'm pretty excited about the global tools. That'll be neat. Span T, memory T, etc. Got Entity Framework 2.1. Talking about things from lazy loading down to there's the Cosmos DB support, which is pretty neat. There is data seeding, link group by, etc. So some neat stuff there. And then the ASP.NET Core 2.1 roadmap post. So this is written by this Dan Roth guy. A lot of good stuff in here. We'll be digging through these in upcoming stand-ups, so that is neat. And then if you are a watching and not a reading type of person, we've got these very cool part 1 and part 2 videos. So this part 1 is kind of a high level, you're on here, Dan, Rich Lander is on. So going through and talking about, here are the, Andrew Peters also is on. And this is, part 1, talking about the features. Part 2, a lot of demos, very cool stuff. And then one other post that just kind of floated by today, I thought was kind of interesting. This just went live today, is this post about this Blazor thing.
Oh my, Blazor.
Blazor. So here's the blog post. But again, if you're not a reading type of person and you're more of a watching type of person, what do you guys got?
Blazor is now an official ASP.NET project. We've brought the project into the ASP.NET org on GitHub. The repo is now live. If you're not familiar with what Blazor is a web UI framework implemented in .NET and C# that runs in the browser via WebAssembly. So you can have a full stack .NET and C# web development solution. That's the dream. Steve Sanderson pioneered a lot of this stuff. He's with us today. You may have seen him demo it at NDC Oslo. He had a sort of like a prototype GitHub repo on his own account. Something he just sort of, one evening he was like, maybe tonight I'll try and get .NET working in the browser. It seems like a cool thing to do, and that's caught a bunch of people's attention. And we've been looking at it for a number of months now. Like, is this really a thing? Like, can we actually make this happen? Is this technically feasible? And we've been doing a lot of investigations and talking to a lot of people about the level of interest in something like this. And we decided, there's maybe something here. And so the project is now in the ASP.NET org. It's a real repo. It's got an issue tracker this time. It is an experimental project at this point. And what do we mean by that? What that means is, well, first of all, right now there's nothing to download yet. It's still really early in the project. If you want to try out something, you can still go to Steve's repo and download the V6 that he has there. But it's just an experiment, which means that there's no committed product yet. We're still trying to figure out do all the technical issues really work out? Is there really demand for this? Does this really satisfy a true customer need? And can we build something that people will love? And so we're having this sort of phase that we're calling an experimental phase, where we can work through those issues and try things out and experiment. But we hope that, assuming everything works out, then this could become a way that you could write web applications using .NET and C# and Razor.
Awesome.
I have a question.
Yeah.
Acting as the audience's like foil. So how do we know that like in 6 months or a year that this won't not be a thing? It'll become a niche thing.
So that is a great question, and that's why we're calling it experimental phase, because we actually don't necessarily know that either. So don't go planning your next critical product website on Blazor yet.
Okay, so this is an official experiment as opposed to Steve messing around at night.
Exactly. We have the ASP.NET team,
but not an official product launch announcement of the future of the Marvel Comics universe.
That is correct. There is no committed RTM, release, official stable release planned at this point. It's still just an experiment. Now we are cautiously optimistic that we can get there. Everything that we've tried out and experimented with so far has worked out amazingly well. and we think we can do it, and we'll need people's help. Like one of the reasons why we're talking about it now is because we want people to participate and give us feedback, even though there's not a committed product yet, so that we can figure these things out. Like what kind of framework would people like? What would appeal? Like how big of an app size is makes sense? How do we what features do we need to have in the framework? Those types of things, so that we can then hopefully eventually make that step to actually turn it into a committed product. But at this time, it's still just an experiment, and that's important, I think, for people to to remember and realize at this stage in the game.
Cool.
Well, that said, we have a lot of cool stuff that you can still see. We don't have bits to share from the Blazor repo yet. We do, though, have sort of like the prototype experience about what we think this could look like. And it's, of course, important to remember this could completely change. We're still trying to figure out what the framework should actually look like. But we have some pretty interesting things to show about what is actually possible today. A lot of this is all made possible by this new tech, which is called WebAssembly. I don't know how much WebAssembly has already been discussed on the community stand-up. But if you don't know what WebAssembly is, like WebAssembly is this amazing new standardized format. Like WebAssembly is a bytecode that you can take any code, like take like a native code base, for example, and you can compile it to this format. It's intended to be a compilation target, and then it can run in any browser at native speeds. So you take code, you compile it to WebAssembly, and you can now run it in any browser at native speeds. That's what WebAssembly is, and it is now supported by all the browsers. Like they all have support for this at this point. And what this does is this completely blows open the doors for what you can now do with web development. Whereas before, web development effectively was essentially only JavaScript. Anything now that you can take and compile to WebAssembly, it is now possible to execute on the web in a standardized and open way. And that's what we're taking advantage of here. We're basically building a .NET runtime using WebAssembly. And it's not actually us, to be clear. Blazor we're just building the web UI stack on top of that .NET runtime. It's actually our friends on the Mono team that are building WebAssembly support for Mono, which actually makes a lot of sense. Because Mono, if you don't know, Mono is the runtime that's used for Android. It's the .NET runtime used for iOS. It's the .NET runtime that's used for Mac. It's basically our client cross-platform runtime. So we're taking advantage of that as extending that Mono to then now also support browser scenarios, browser client scenarios.
So back the original kind of release thing that Steve did at NDC that used .NET Anywhere.
Yeah.
Right?
Yeah.
Okay.
Steve, do you want to talk a little bit about what you did there originally?
Yeah, sure. Okay. So quite a while back when I first wanted to experiment with this, there was no commitment from the Mono team to port Mono to WebAssembly or from anyone, in fact, to do that. So the only way of getting .NET to run inside a browser on WebAssembly was to find a really simple .NET runtime written in just a very simple variant of C that I could compile to WebAssembly, because that's what the WebAssembly compilation toolchain lets you do. And I did find one written by a guy called Chris Bacon, which was written about 5 years ago, something like that, and has not really been developed since. But it was very small and simple, about 100 files of C, and that was possible to compile to WebAssembly. And that was the basics of getting .NET running in the browser. And so I was able to build a little UI stack on top of that. And so that was the original prototype. But since then, like Dan has said, the Mono team have said that they are bringing the full-fledged Mono runtime to WebAssembly, and that means that we have a truly production-grade .NET runtime. And so the newer version of Blazor that we're working on now is based on the Mono runtime, which is far more powerful and complete than .NET Anywhere ever would have been.
What is the difference between taking Mono and compiling it to WebAssembly and taking .NET Core and doing that as well?
Okay, so, all right, so the thing that we're interested in compiling to WebAssembly in the first place is the .NET runtime itself, not your .NET application.
Understood.
So yeah, for anyone who hasn't quite grasped the difference there, it's the thing that loads and executes the .NET assemblies, okay? And that needs to be supplied to the browser in WebAssembly code itself. Now, if I had a way of compiling the regular CLR, whether that's the regular desktop CLR or whether that's the newer Core CLR, or some other thing like Core RT, then I would have done that. but these are massive projects, and doing
As is Mono.
managing. Yeah, that's right. Yeah, so these are really large, serious projects that you can't just get one random person just decides to compile it to WebAssembly. It requires a huge amount of additional work and support in the runtime itself for an entirely different platform, which was completely beyond my capability to do last year. So that's why it was using DNA, which is just a tiny, simple thing that one person can figure out on their own. But yeah, since then, the Mono team themselves are bringing Mono to WebAssembly, which is a huge engineering job, but they're doing that.
Sure, I was just curious why pick that huge engineering job versus the other huge engineering job.
Well, I think part of what would help understand that decision is also to think about how these runtimes today typically get used. Like .NET Core today is pretty much a server runtime. It is primarily targeted at server workloads. It's ASP.NET, it's EF on the server. Whereas Mono today, it has some server support, but it never really came of age. It never really got fully baked. It's mostly a client runtime. They primarily use it for client platforms like Android, iOS. And so
that's a good point.
We're building a client story here, like we're working in the browser. So actually Mono makes a lot of sense. It is a client stack.
So then let me
longer term discussion here about like, does it really make sense?
No, because you just answered it perfectly, and I'm agreeing with you now, because you ever heard the term strong opinions weakly held, right? Yeah. I don't really have an opinion, but now I'm starting to realize exactly why this makes sense, because Mono is also known for its extreme portability. As a code base of C, there's Mono for PlayStation 2 or whatever kind of obscure, like it's a really great portable runtime. And keeping in mind that .NET Framework, .NET Core, and Mono are each instances of .NET, each of which supporting the .NET standard, we're going to be able to take .NET standard DLLs and load them up. And whether or not Mono was the runtime or not, it doesn't matter, because it's an instance of .NET that's going to run in the browser now.
That's actually exactly right. In fact, so for Blazor and for Mono on top of WebAssembly running in the browser, we will support .NET Standard 2.0. So you will be able to take .NET Standard libraries and use them in your Blazor applications. There, of course, will be APIs in that surface area that like don't really make sense in a browser.
No, but
those will throw platform not supported exceptions like you would expect.
When I started exploring the .NET Standard on stage at conferences and presentations and stuff, I went and took a 17-year-old app that I wrote for school, and I compiled it and ran it on a Raspberry Pi. So on ARM, on a device that didn't exist 17 years ago, and you're telling me that in a couple of months, years, whenever, I'm going to be able to take my 17-year-old school project, which is a nice, clean, even .NET Standard 1.6, and run it in the browser. Code that I made that is a decade plus old, it will be portable, assuming it is reasonably portable code.
Yep. Assuming it doesn't touch anything that doesn't fundamentally make sense.
I'm not looping through the registry.
Yeah, exactly.
So there are a few people asking in the chat saying, they like .NET Core because it's new and they feel like it's supported and all that, whereas Mono they're worried about it being, supported.
They're using Mono now on their iPhone and their Android and on all over the place. Though Mono is a .NET, it's an open source project. It's a Microsoft property now. It is a supported thing. You're using it today.
Yeah, I think a lot of people, when they think of Mono, they think of like this sort of side project, but actually Mono is a core part of the business strategy of what .NET is. Like if you want to get .NET running on a mobile device, you are using Mono today, and that is fully supported, and we pour tons of resources into making sure that works well. So it's not something that's just like going to disappear. Mono is a important part of the .NET ecosystem. It's also, by the way, the runtime that's used for like games, which is another great scenario for WebAssembly. If you want to get, really fast, rich games running in the browser, like you want to use Unity and you want to do your coding in C#, WebAssembly, great underlying tech to do that with, and Mono is actually the runtime that's used by that stack, by the Unity stack. So
good point.
There's another case where Mono is heavily invested in.
Yeah, cool. The fact that we're using Mono all day long, constantly in production, on Xboxes, on all kinds of things, on Switches.
Cool. Yeah, and as pointed out too, people are talking about in the chat that, because now everything's like .NET Core is open source, code can be shared between the two pretty easily too.
Yeah, and we do that quite a bit. I mean, I was talking about more of a long-term strategy for what we have these. We do have multiple .NET runtimes, and maybe at some point it will make sense that these things should be reconciled. Like, let's not pay the cost of having 2 different runtimes. Maybe at some point they do this magical merge and everything works seamlessly together. That's obviously a fairly expensive thing to do, so that doesn't happen overnight or even in the course of just a year or two. But they do today. The strategy is they share code between the 2 projects as much as possible, so that there's as much consistency, and to also to keep costs down of maintaining the different runtimes.
Cool. Well, do we maybe get to see any demos today, or?
Yeah, let's see a demo. Steve, do you wanna show us what Blazor could conceptually look like?
Yes, I will. Okay, I'm just sharing my screen now. All right then. So I will show a demo that that we've been doing for a little bit. What I'm going to show you just now is not based on the absolute latest version of the Blazor code base, but rather goes back 6 months or so to the previous prototype. The reason for that is because that previous prototype was a little bit further ahead, but the code for that previous prototype was just a massive train wreck of just anything that I threw together in 10 minutes because it seemed to work. Which is, how we were able to get fairly far ahead fairly quickly. But our new
prototype code, as opposed to now actually having to write product code.
Yeah, that's right. Yeah, our new repo in the ASP.NET org that contains only production grade code, so it's far better, but it isn't quite as far along just yet. Although in another month or so it should be. But anyway, that's why the demo that I'll show you just now is based on the earlier prototype. And I know some people may have seen this particular demo on YouTube before, so apologies to those people. But for anyone who's new to this is a good place to start. So let's say that I want to create a new Blazor application, which, like we've been saying, is a .NET application that runs inside the browser. So we've got a project template here. I'll go new project, and I'll call it Standup. Okay, and I'll create that new project. And that is going to obviously lay out the initial file structure of the application, like all projects do, and it's going to pull down the various NuGet packages that I need. And I'm just going to check that actually has restored those packages, and I can build. Let's see if we can. Probably. All right. Anyway, I'm going to run it in a browser now, so you can see some initial UI, and then we'll look at the code. I'm doing a Control F5 there, and that's going to pop up in this browser tab. And it takes a second to come up the first time because it's doing some compilation in the background. But when that does come up, you'll see it looks like a pretty traditional looking single page application. So it's got a few different pages that the user can navigate through. It's got this example of a counter that just counts how many times that you click the button. And it's got this fetch data page that demonstrates doing an HTTP request to the backend and just trying to get in a table.
Steve,
other features that, yeah.
I'm hearing some audio dropouts. I don't know if other people are too.
Yeah, you're fine, and then you fade out to almost nothing.
Yeah, make sure that you're not turning your head at all. You disappeared for a good 10 seconds there.
Was I now? Okay.
Sorry, sir.
Okay. I will. I can switch to a different microphone. Right, 1 second. Okay, can you hear me now?
Yep.
Yeah, I can hear you.
All right then. Okay, great. All right then. So here we are inside this Blazor app that we've just created. And as I was saying, and I don't know if you heard me, we've got a few different features just out of the box to demonstrate stuff. So we've got backwards and forwards navigation there. We've got this counter that counts how many times you click things. And we've got this example of doing an HTTP request to the server and displaying some stuff as a table. So it's the sort of thing that you would traditionally build with a SPA framework like Angular or React, but it's not Angular or React, or it's not any JavaScript framework at all. If we look at the code in the application, you will see that we don't have any JavaScript whatsoever. All we've got is HTML, we've got some CSS, and we've got various C# files. And the C# comes in 2 different flavors. We've got regular C# files, such as this program.cs, which is what we're running when the app first starts up. And that's dealing with booting the application up. And then we've also got these CS.html files, which are Razor files. And I think most ASP.NET developers will recognize that. It's a way of mixing markup with C# code. So as an example of that, this counter page here, if you remember what the counter does, it's just displays this button. And when you click the button, the count goes up. And the code in there is pretty straightforward. We've got this current count property, and we are displaying the current count. And we've also got a button that when you click it, it's going to call this method increment count, which just increments the count. So it's a very, very simple programming model that we can use to build these components out of. So each one of these CS.html files is a component, and we can construct the application out of components. We can nest them, we can share them across projects and all sorts of things like that. Does that make sense?
Yeah, that functions then, is that new?
Functions is not new. Functions as a feature has been in Razor for a little while. It's a way of just adding arbitrary C# code. Yeah, it's more widely used in Razor pages than it is in MVC, but you can use it anywhere that Razor is used.
Okay.
Okay. So shall I implement a bit of functionality on top of this so you can see what the developer experience could be like in this world?
Sure.
Something more than a button click.
Yes. All right then. So let's say we want to do the thing that everybody always does, which is a to-do list. All right. So I want to add a new item into this navigation menu here that says to-do list somewhere so the user can navigate to it. Okay. So I'm going to move my browser down here a little bit so that you can see my browser at the same time as you can see the code that I'm working on. And I want to add a new link to to-do list. So I'm going into this file navmenu.cs.html, and that represents stuff that's over on the left. And I'm just going to do a bit of high quality copy and pasting code here, where I paste a new list item, and I'm going to type in a URL for it, and I'll say that goes to to-do list. And then also I'm going to set the text on that to be to-do list. And now I'm going to press save. And notice that when I press save, I don't have to switch back to my browser. It just updates automatically. So now we've got to-do list on the menu there. And I can click on that. And it seems like nothing happened, but something did happen, which is that the URL has been updated now to to-do list. But there isn't any page matching that URL, so it's not doing anything just yet. What I will do is I will add a new component called to-do list. So I'm going to go add new item, and we don't have a proper item template for this yet. So I'm going to choose MVC view page just because it happens to give me a Razor file, and I'm going to call it to-do list.cs.html. And when I hit add on that, you should see the browser updates again because now there is a to-do list, but it's just blank. We haven't got any content in there yet. So let's put some content in to-do list. And when I press save, you'll see to-do list shows up over there. Okay, so since this is Blazor, we can do some arbitrary C# code here, which is going to run in the browser. And I'm going to do that with one of these functions block that we just talked about. And I'm going to model a to-do item as a class. So let's have a class called to-do item. And we'll say that each to-do item has two properties. We'll have a string called text, and we'll also have a bool called isDone. Okay. And of course, we don't just want to have one of these things. We want to have a whole list of them. So in the obvious way, I will have a list of to-do items called items, and I'll set that to be a new list. Okay, good. And if I want to, I can use Razor to display some data that I've got. So I can get all the usual IntelliSense. I will display items.count. And when I press save, you should see that there are 0 items in my to-do list. Okay. Now, I know that that to-do list is empty, but before we start adding stuff to it, I want to just try and display the contents of the list, even though there isn't anything in it yet. So I'm going to do an HTML unordered list. And using Razor syntax, I can say for each var item in items, I will have a list item, and it's going to display item.text. Right, I'll save that, and it doesn't appear to do anything initially because my list is still empty, so there's nothing to show. And I'm going to add a button, and I will say the text will be add item. All right, so I've got my button, and when I click this button, absolutely nothing happens, which is not surprising because I haven't wired up any behavior on this now. So how can we add some behavior to our button? Well, if we were going to do some really old school JavaScript, we could say something like onClick equals, and then we just type out some JavaScript stuff in there. But because this is Blazor, I can do it with C# instead. So I can say, when you click this button, items.add, we'll add a new item, and we'll add a to-do item with the property text set to whatever. We'll figure out the details of that in a minute. All right, so let's see if it works. I've saved it, and now when I click add item, it does indeed add some items. Yeah. Okay,
One of the things
good.
I love about watching this is like you saw when he's writing the C# and that attribute, like you get the beautiful razor IntelliSense that comes from the editor. The tooling is just fabulous. It's really nice to see.
Yeah, and much of the design around this is to make the most of what the tooling can already do. And I can show you some cool examples of newer things we can do with the tooling in a minute. All right, then. So I know that some people watching will be going like, oh, no, seriously? You don't expect me to put loads of C# into HTML attributes? That's disgusting. So no, don't worry. That's not the hot new thing. A much more reasonable way of adding behavior would be to have methods. So let's say I have a method called add item. Okay, and I want to just cut the code that I've already got from there, and I'm going to put that into my add item method. And then I'm going to use a bit of shorthand to say, when this is clicked on click, we will call add item. And that's just equivalent to writing on click equals add item, but it gives us proper type checking to make sure we don't try to call a method that takes the wrong set of parameters or whatever. But it will behave the same. All right, so our code is a little bit more readable now. What else do we want to do? Well, we don't really want to hard code this word whatever. We want to have some way for the user to type stuff in. So let's have an input, and I'll put type here. Okay.
So we've had some questions if you can show the network debugger.
Yes.
So people can see. People are really interested in how this is actually connected.
Like what is this actually doing?
Yeah, absolutely. All right. So
this is what's trippy.
All right then. So this is what we're loading into the browser right now. And let's just go down this a little bit. Okay, so we've got the initial HTML document, which everyone's familiar with. We've got some CSS stuff because we're using Bootstrap. Then we're loading the Blazor runtime in JavaScript. And that knows how to start up the whole WebAssembly runtime and load Mono into it. Well, in this case, this is, like I said, this is the earlier prototype, which is based on .NET Anywhere. But if you use the newer code, it would be loading mono.wasm. But the old prototype loaded this WebAssembly file, dna.webassembly, and that is the whole .NET runtime that can load assemblies, it can execute them, it does memory management, it does the garbage collection, it does all the .NET kind of stuff. And then it in turn is choosing to fetch actual .NET assemblies. So these are regular net standard .NET assemblies. They are just the normal things built by the normal C# compiler, and the same assemblies that would run under the normal .NET runtime on the server or anywhere else.
That's a really cool thing. That when I've played with this before, and I expected maybe to see those as WASM, or I didn't know what they were going to be. That is really interesting. So those are straight up just standard .NET DLLs.
Yep.
They absolutely are. That is correct.
So one other thing I'd worry about seeing this is dna.wasm or mono.wasm going to be 6 megabytes or 10 megabytes or 4,000 megabytes?
Okay, so dna.wasm, it's in this case is 74 kilobytes, which is pretty reasonable.
Yeah.
The entire application here on this old prototype is tiny. It's 340 kilobytes. Now, when we switched over to mono, we got a rather significant increase in that size because mono just does tons and tons of stuff that we don't even need it to do. So there's a major bit of optimization work we need to do. I don't think we're going to get mono ultimately down to be as tiny as this DNA one, which is only 70 kilobytes. I think it's still going to be larger, but we're quite determined to keep the total application size down to a reasonable amount, which, what's a reasonable size? If you ask different people, you'll get different answers, but I'm quite determined it's going to be, under a megabyte. We'll see.
Okay. And last question is, can that be cached in the browser?
Oh, of course. Yeah. So whatever size it is, it's a one-time thing. and it could be loaded from a CDN so that the user only pays that cost once for all Blazor apps that they ever use. So it shouldn't. Hopefully, it won't really even be big enough to be noticeable on the first ever load, but absolutely, it should be completely cached for subsequent loads.
Yeah. So you're literally, this is just normal .NET assemblies running inside the browser on top of a .NET runtime that's implemented in WebAssembly. And there's no plugins, there's no transpilation to like JavaScript or anything like that to make this work. It is literally just a normal .NET runtime, happens to be implemented in WebAssembly, running normal .NET assemblies. That's what this is doing.
Exactly
So
what this is.
I have a question about overhead, because JavaScript is a virtual machine, and while WebAssembly is a binary format that's very clean in implementing in doing stuff, this is a virtual machine implemented on top of a virtual machine, then running some instructions.
Yes, that is correct. Yeah.
So does that, do you have a sense of how heavy that is?
It's definitely not going to be as fast as running it on whatever the closest.
Like comparing it to like people using C and C++ and compiling that to WebAssembly.
I can't really give you any numbers on that.
Yeah, I guess I'm not thinking about, like, I'm not asking you to give me like milliseconds or whatever, but I'm wondering as far as like degrees of overhead, or is it 10x, or how much weight is there, and is that really something even to think about, because it seems fast?
Well, yeah, okay. So when it was on DNA, I did a little bit of experimental benchmarking, and I was finding that just doing pure CPU heavy things was about 10x slower under DNA on WebAssembly versus the regular desktop CLR. Okay.
But does the concept of jitting even exist?
It could exist, but it's definitely not implemented in DNA, and I don't know that Mono necessarily has any definite plans to that.
So it was an interpreter at that point.
Yes, exactly. Yeah. Now there are a couple of reasons to think that this is not necessarily going to be a problem. One of them is that this is fundamentally about building client apps. So it's not like with server apps where you absolutely need to get the maximum throughput that you can, because otherwise, your business is paying whatever proportion more for its cloud hosting costs. With a client app, you are fundamentally distributing the workload to your clients. So, you're not directly paying for that. The only thing that really ultimately matters for a client-side application is it fast enough that human beings don't perceive any lag? Because there's no point in being faster than that. It doesn't benefit you significantly. So as long as humans never think it's even remotely laggy, you're okay.
Okay.
And, that appears to be entirely achievable.
Right.
I would say also that comparison that Steve mentioned was done between, a desktop .NET runtime and a runtime running in the browser. I think where we'll probably spend more of our time is like, how do we compare against existing JavaScript experiences if you're doing the same type of heavy computation in the browser, but doing with JavaScript as opposed to trying to do it with C#. I mean, obviously, we don't want to have like a significant regression there. Like that should be at least on par, if not even faster. Because we are fundamentally running on top of a runtime that's supposed to be running at native speeds thanks to WebAssembly. So we do benefit from a low level, like WebAssembly is very low level piece of infrastructure. Yes, it is implemented by the JavaScript runtime, but it's a compilation target. It's not intended to be a high level interpreted language to say. It's supposed to be fast. You take C code and you run it in the browser and you basically get comparable speeds. So runtime performance, I'm honestly not too concerned about. The download sizes is where I'm expecting that we'll have more need for investment and optimization to make sure that when you download the app in production or during development, that you're not downloading megabytes and megabytes of stuff.
Couldn't you, just like we stick jQuery on a CDN, you do the same with the .NET runtime in WebAssembly?
Absolutely. Yeah, that's one trick we can leverage. There's technologies like the Mono folks have a linker technology where they can go through your app and strip out all the IL that actually isn't really being used by the application, all that sort of trimming, stubbing out whole assemblies that you don't even need. Like what currently the Mono folks have done actually is they took the entire desktop Mono runtime and ported it to run on WebAssembly, which is obviously way more than you typically need for a browser app. So there's a lot of opportunity there to pull out stuff that doesn't apply to browser apps at all. And we have a bunch of ideas about how we can get that size really small. And in fact, Steve's already done a bunch of initial very early, short time frame investigations that look very promising.
Wow.
Yep.
Cool.
Okay.
This is very cool. Thanks for putting up with those questions.
No worries. And just on that same subject, one other thing that the Mono people have told us that they're working on is ahead of time compilation. So under that model, when you publish your application, what you would end up getting is a set of WASM files, WebAssembly binaries. And so the thing that you ship into the browser is no longer .NET DLLs, but rather each of them has been pre-compiled to a WebAssembly binary, which should run at really close
okay,
to
so
regular
hang on.
desktops.
Compiled to a WebAssembly binary, not a .NET native like situation, but it's pre-chewed. It's halfway to apple juice. It's applesauce.
It's kind of analogous to that in some ways.
It's the IL equivalent of WASM.
It's as low level as you can get
without actually being proper executable code. Like, would it still need the jitter and the CL? Not the jitter. Would it still need the CLR and the garbage collector implementation?
Oh yeah, it totally still needs the runtime services like that. Yeah.
So it's just pre-chewing your food.
It's very close to being as good as you're going to get with.
That's awesome.
Running regular desktop.
The potential for this is bananas. Like, as long as people understand what they're getting into, the potential is banana. It's just insane.
So the two things, like the first thing that I always thought of and heard of when I would hear WebAssembly is like, wow, performance, native speed on the browser, which is cool. But a thing that Dan pointed out early on too is the language, like you can write in whatever language will compile to. Like in this case, you're not even worried about that. You're just writing C# code. Anything that'll compile to MSIL, you're set, right?
Yep, that's right.
That's right.
Yep.
If you wanted to write an F#, I mean, what's happening in Steve's project in that Blazor app is it's actually taking those Blazor files, I guess, or Razor files, and compiling them into an assembly, and then just pushing the assembly into the browser, downloading that assembly into the browser, and then running it using that .NET runtime. I don't know if you look at the network trace, you see there's that .views.dll. That's the actual compiled Blazor app views, those CSHTML files that have been compiled, changed into a type, and then compiled into assembly, and then downloaded into the browser so they can be executed to update the DOM and do those sorts of things.
So am I going to get confused when I'm writing Razor code as far as what's going to be executed on the server and on the client?
No, I hope not, because the simple answer is in a Blazor application, everything is running on the client. So it's not like it's partially running on the server and partially on the client.
Well, everything, but like I want to talk to the SQL database and make some JSON.
Well, okay, you'll be just as confused as you would be if you were writing a mobile app or something like that, where the client needs to make a call to an API backend.
Okay, so then this is more about we used to call these chubby clients in the Silverlight day. It's like take some work that the server was doing, but it's just not necessary because you have a smarter client now, and have the client do that work.
That's
For
right.
a lot of things, you could do that. And then for other things, you would just make web API calls to, like, say, an ASP.NET Core backend and have the server do the normal work. And then you just get some, like, a JSON payload back that you use to update the client experience.
So I have a solution. I have a solution with two projects. I have a Blazor application and I have an API application.
That's exactly, yeah. In fact, I could show you an example of that in a second. Actually, let me just
finish your demo.
Just forwards.
Sorry, and we interrupt you because we love you.
Just because there's a couple of things I want to show that will get people thinking a little bit more about the broader set of ideas that are going on here. So just the last bit I want to add to this is to be able to capture what the person types in there and add it to the list. So let's say we're going to capture whatever's been typed into this string, and I'll call it new text. Okay. And then I'm going to say, I want to bind whatever gets typed into this text box onto this new text variable there. And then instead of using whatever, I can use new text. Okay? And when you press the add item button, I also want the text box to get cleared out automatically. So I'm going to say new text equals null there. So now when the user comes along, they can type stuff in, and whatever they've typed in gets captured. It worked. Okay. Now we could go further than this. We could have checkboxes to mark things as done or whatever. But I want to just bring up a couple of other interesting related concepts. So the first one is, what about browsers that don't support WebAssembly? Now you might think this is a bit of a critical issue, because even though all the latest browsers do support it, there are still plenty of legacy browsers that are never going to support WebAssembly. So let's see what happens if I try to run our to-do list in Internet Explorer 11, which absolutely does not support WebAssembly. Okay, so I'm going to paste in that URL. that we just had. Apologies for all this mad stuff that appears in the and what happens is it just pops up and it works. And it works exactly the same as before.
But wait, but the thing, like Internet Explorer doesn't support WebAssembly, right? When I said all the browsers, I meant all the modern browsers,
Yes.
Chrome, Firefox, and Edge. All those guys, they support WebAssembly, but this doesn't.
It does not.
So how does that work?
Witchcraft. What is going on?
So WebAssembly, when it was spec'd out, it was designed specifically to be quite close to what existing JavaScript virtual machines could do. And a consequence of that design is that it's quite easy for anything that you can compile to WebAssembly, you can compile to a slightly different but similar format called ASM.js, which can be executed by just standard JavaScript runtimes going back for years and years and years. And so that's what we've done in this case. When we've compiled the .NET runtime to WebAssembly, we've actually compiled it in two flavors: one, true WebAssembly binary, and secondly, as an asm.js file. And then when your browser starts to load your application, we can check, does it support WebAssembly? If it does, great. If it doesn't, then we're going to load the asm.js version of the runtime instead, which is also going to work. The reason we don't always use asm.js is because it's bigger and it's slower. So you don't want to do that all the time. But for browsers that don't support WebAssembly, it's a pretty good fallback option. Okay, so that's one cool thing. Another cool thing is debugging. So let's say I've got an application like this that I want to debug. You might want to connect to it from your IDE, like Visual Studio, to attach a debugger, although it's kind of hard to see how that's going to work. Like, how is the browser going to know that it's supposed to let you do this? But also, if you're developing web applications, often you are going to be more productive not using your IDE, but using the browser's built-in dev tools, because then you can see all the things like the element inspector and the CSS styles and such like. So here's a prototype idea that we came up with for enabling debugging in this environment. In order to show you this, I'm just going to switch over to a different project. Now, this is structured in the way that John just described. So it's got a client app, which is Blazor, and it's got a server app, which is regular server-side ASP.NET, that's going to serve the client app. And it's also got a shared assembly, just to demonstrate the fact that the same assembly files can be used both server and client. But anyway, that's just a minor point.
Nice.
What I really want to focus on is the debugging stuff. So when I bring that up in a browser, you'll see it looks more or less the same as before. It's got a counter, even though it looks got some slightly different features. Like we've got a demonstration of interop with third-party JavaScript libraries, blah, blah, blah. Anyway.
Just blah, blah, blah. But if in case you didn't notice what that was C# running in the browser on top of a .NET runtime, calling into JavaScript from C#. So you can do JavaScript interop both ways, actually. You can call from JavaScript to C# and C# to JavaScript. That's all enabled by the underlying WebAssembly tech. So that was super cool. That was basically, wow. I think that was a Bootstrap modal dialog, right? That you just popped up there. You called it Bootstrap from C# in order to pop up that dialog. That's super cool.
I mean, while you're showing that, can you show the source for that?
I can, but it might not look nice because this is the old one. This is not our newer, nice to look at.
All the hacking stuff to get stuff working. But yeah, that's amazing that could be made to work.
Sure. Let's see how it looks. All right, so we've got this show modal document, get element by ID mode. All right, yeah. So I wrapped it all up in some class called modal, and let's see what that actually does inside.
So some low-level p-invoke like API to like call JavaScript.
So we have this weird abstraction called JS object, but we're not doing that in the newer version. It's much cleaner and more sensible than that.
And we've even talked about also like having tools that can generate like C# wrappers around JavaScript libraries based off of their TypeScript definitions. So you could even have like a strongly typed, like basically call Bootstrap as if it were C#, like using an API that looks like it's actually a .NET library, which would be super sweet.
Correct.
This Silverlight old timers will remember there was a JavaScript bridge there. This is just, it's cool to see the same programming.
But there's no plugins here. This is just open standards. Like this is just open tech. That's the beauty of it. It runs in any browser that supports the latest standards.
I had a question from Christian. He's asking if it produces source maps.
Does it produce source maps? It does not produce source maps under the interpreted model, because for an interpreter, source maps don't make sense. The whole concept of source maps relies on the idea that for every instruction location in your binary, there's a corresponding source location. But that doesn't work at all for an interpreter, because think about what an interpreter is doing is it's looping over some standard bit of instruction that says something like fetch the next instruction, look at what type of instruction it is, do a different thing depending on what type of thing it is. So a source map can't represent that sort of thing. It just doesn't work. However, if we support ahead of time compilation, then a source map would work. So there might be a reason to do source maps in the future, but there isn't at present on the interpreter model. Does that explanation make sense?
Yeah.
All right, great. All right, so if you don't have source maps, that makes it seem like debugging wouldn't really be possible. But watch this. I'm going to press on my keyboard now, Control-Shift-D, which is just a magic key combination that I've made up. And what that's going to do is pop open a browser debug window. Okay, so what's that? Well, it looks like the normal Chrome debugger. In fact, in order to see it better, let's just put it on one side like that. Okay, so it's got all the stuff that you would normally expect the debugger to be able to do. So I can do the element inspector, I can look at the network trace, I can do profiling, all that kind of stuff. But what's a little different is, if we look over here, you'll see we've got all of our .NET assemblies listed as well. And if we look inside there, we can see the C# files as well. So here's the C# stuff that runs when the application starts up. And also, if we look in here, we can see all of our Razor files as well.
Whoa.
I can see now my counter page over here in the Chrome debugger. And better still, I can set some breakpoints on it.
Now, their tooling's improved a good amount on this, right? Because I remember trying to mess with this, I don't know, months ago, and it didn't seem like it did all this.
Yeah, this is a more recent bit of prototyping work. Yeah,
okay,
that is correct. Yes. So just for anyone who wasn't sure whether to believe this would work, if I click on this increment button now, you'll see we're paused in debugger here.
What?
We've hit our breakpoint over here. And we can do all the stuff like pressing F10 to step onto the next line if I actually focus in the right window, and then continue execution, and it all works in the way that it should. So anyway, this is a prototype. This is just a very limited. All we've made work in this prototype is hitting breakpoints and stepping, so really limited. But the basic concept could be extended to support all the debugger gestures that exist. And so we are talking to the Mono people, and hopefully they are going to enable debugging in some way, a bit like this, but we don't know for sure just yet.
Cool.
Okay, that's probably. Oh yeah, one last thing. Do you want to see one last thing, or
sure?
Are we short on time?
I mean, we should see one last thing relatively quickly.
All right. Okay. So one last thing is on the newer code base, on the real implementation of Blazor in the ASP.NET org, where all the code is clean and everything is good and it works properly and it's not just hacked together, we've done a little bit of work on making the tooling much better. So if I go into here, let's say, no, in this one. Okay. So this, I just want to show you how we could compose different components together and give you nice IntelliSense like you're doing. So let's say you want to create something called a special notice, which is a component that displays some data in a particular way. So it's going to take in a title and content, and it's going to take a callback that should run when somebody clicks on an OK button. So it might look a little bit like that. And that's in a file called specialnotice.cshtml. So just the fact that I've got that file there on disk means that I can use it in a different Blazor component. In this Blazor component, we've got a Boolean that gets set. Who cares how it gets set, one way or another. And we're going to say, if we want to show notice, then what are we going to do? Well, then we will have the special notice. Okay. And we're going to get full IntelliSense and all that. So the title is something happened. Okay. And then I can put in some arbitrary stuff. And I can use C# stuff if I want to, like that. And then I also going to get the ability to reference other things with proper type checking as well. So let's say I want to run some code when the user clicks the OK button. So I'm going to add a function. Let's say void dismiss notice. And show notice equals false. And that would make the notice go away. And then to run that, I can say on OK, let's say dismiss notice. Okay. All right. So then I've got proper type checking on that as well. So if I was had a method that takes some parameters, then it would hopefully tell me off for that. That we got the red squigglers have appeared, and it knows that's not right. But if we've got the right method signature, then that's all going to work. So anyway, that just gives you an idea of how you would compose different components together and pass parameters between them and deal with callbacks and get IntelliSense and all the right type checking and that sort of thing.
So in Blazor, you like define new components just by authoring a CSHTML file, or just authoring a Razor file. And then you can use those as components in other components and other parts of your app using the sort of normal tag-like syntax.
That's right, yeah.
And you get full IntelliSense over that. You'll get completions. Wow.
That's right. And so when you compile...
Is that similar to like conceptually for other things, there's tag helpers and there's view components. Is it similar to those, or is it just kind of, it looks similar?
It's similar in the sense that they're all ways of reusing and composing bits of UI. It's different in the sense that fundamentally what we're trying to do with Blazor is a stateful client-side UI system. So with Blazor, you're dealing a lot with how things change over time, as opposed to with server-side code, it's always one-time render. And so you're really dealing with a different set of concepts.
Yeah, I feel like this is something where, just thinking of me as a developer, this is something where I'm going to have to wrap my head around it a bit. Like, I'm going to keep thinking of like, oh, I'm generating HTML on the server and shipping it to the client. I've got to get out of that mindset, of like, this is
all client-side. All the state can just stay right there, and you can do things and with stateful components in the client side, a composable UI in the client with .NET.
Wow.
There you go.
Looks good, Steve. That looks great.
Yeah. Okay. So where we should probably wrap up. Let's remind people of where they can, like, where are we at again? Where do we go to find more? Where do we keep up with all this?
So check out the blog post. We posted a blog post about what we're doing with Blazor. The repo is now public. This is an experimental project. It's not a committed product yet. It's very early. There's nothing to download yet. This isn't a release announcement at this point in time. If you're really adventurous and you want to try out the bits that are in the Blazor repo, you can clone the repo, you can build it, you can try running the tests. That's what you can do right now. If you have questions like that we didn't answer here, we have a FAQ in the repo that you can check out that answers all sorts of things about WebAssembly and our use of Mono and what we're trying to do with Blazor. So check that out as well. If you have suggestions or you find bugs in the code, you can send us PRs. You can file issues in the public issue tracker. We do have an issue tracker this time because we do care. We do want to hear about what people think about what we're doing. And yeah, if you want to see a live Blazor app, also there is a Blazor app that Steve put together and published to Azure that if you want to like F12 and see what it's downloading, the one he published to Azure is actually based off of Mono, so it has more runtime capability and more stuff that you can see what's there. That's at blazor-demo.azurewebsites.net. There's a link to that in the blog post as well. So if you want to play around with an actual Blazor app yourself, you're welcome to do that. And the bits that Steve showed, the prototype bits, they are still available. If you want to mess around with that project template, you can get that off of his GitHub repo at stevesanderson/Blazor.
Very cool. Awesome. One last question I just want to jump in with. Johan asked, can he redo Steve's demo at his company? He wants to show this off.
It is public. It is open source. Tell your friends, tell your mother, tell anyone you want. Like this, there's nothing secret here. The cat's out of the bag. And yeah, show it to everyone you want. And like one of the things we really hope is that in addition, like obviously this will have appeal to people who do .NET today and like doing .NET development. We hope that this will also be something interesting to people that don't do .NET development today, but are interested in a full stack development story that has great tooling, great IntelliSense, all the security and performance of .NET running both on the server and now also on the client. So feel free to show it to everyone, anyone who you think is interested in the latest developments in web development. We'd love to hear what they think as well.
Great. Okay. With that, I believe it's time for the dramatic zoom out.
Oh, okay. You ready?
Dramatic zoom out. Dramatic.